In section 6.2, we factored trinomials of the form x squared plus bx plus c. In section 6.4, we're going to factor trinomials of the form ax squared plus bx plus c by using a method called grouping. We touched on grouping a little bit in previous section. I think we did it in 6.1, but I want to let you know that I didn't do a video for 6.3. 6.3 and 6.4 teach two ways of doing the same thing, and I like 6.4's method better, so that's the one I'm going to teach. We will go back and look at a couple of concepts in 6.3, but I wanted to do this one first. So factoring by grouping is also called the AC method. If you're looking something up on YouTube or somewhere else, you might want to look it up under the AC method. And what the A and the C represent are the coefficients of the x squared term and the constant. Notice in the formula, there's an ax squared plus bx plus c. The A and the C come into play when we factor using these methods. And what we're talking about now is that in section 6.2, we didn't have a coefficient in front of our x squared term. Remember, I kept saying, is the leading coefficient a 1? The leading coefficient was always 1. And so when the leading coefficient was 1, we just started factoring by placing our parentheses, and then we could easily determine our factors there. But now the leading coefficient is not going to be 1, so there is a process that we have to go through to factor these. It's not as straightforward. So I've given 3 examples here. 7x squared minus 4x minus 11. That's an example of a trinomial where the leading coefficient is not a 1. Then 10x squared minus 9x plus 2. That's another one because the leading coefficient is a 10, not a 1. Then 21x squared plus 17y plus 2 has a leading coefficient of 21, which is not 1. Now, let's recall how we factored a 4-term polynomial. I'm going to kind of ease you into this. Remember, if we have a 4-term polynomial, and if those terms can't be combined any kind of way, the way you always approach a 4-term polynomial is by grouping. So if we group the first 2 terms in this polynomial, 5x plus 15 plus xy plus 3y, if we group them this way, because they have something in common, the 5x and the 15 have a 5 in common, the xy plus 3y have a y in common. If we group them that way, then we can factor out a 5 from the first binomial, and it leaves us x plus 3. And we can factor out a y from the second binomial, and it leaves us x plus 3. Remember, your goal is to get 2 of the same binomial in each one of those expressions. So then we factor out x plus 3, and we are left with 5 plus y. Okay, so if you have 4 terms, you always want to group. In fact, if you have 4 terms, that's the only way you can group them. Okay, if you have 4 terms, if you have 4 terms, you have to use the grouping method or the AC method to factor. So let's look at the next example. The next example, I can group the first 2 and the second 2. If you wanted to rearrange them, you could, but it doesn't make sense to rearrange them here. So what can we factor out of the first binomial? 2 and it leaves us a y minus 4. And in the second binomial, we can factor out an x, and it will leave us y minus 4. And then we take our y minus 4, which is common to both of them, and then we're left with 2 plus x. So we have taken a 4-term polynomial and grouped it and ultimately factored it. Okay? We've done those before. Now, look at this. Suppose we have this 4-term polynomial, x squared plus 3x plus 2x plus 6. Now, notice that the two middle terms are both x terms. But I don't want you to combine them. I want you to see that separated like this, it makes 4 terms. If we combine them, it'll be 3 terms. Okay? I want to leave it as 4 terms. Leave it as 4 terms, and then let's group them. I'm going to group these two and these two with parentheses. Then we can factor out the first one. We can factor out an x, and it leaves us x plus 3. The second one, we can factor out a 2, and it leaves us x plus 3. And we factor out an x plus 3, and we're left with an x plus 2. So we took that 4-term polynomial, even though they had some terms that could have been combined, we separated it into 4. We left it as 4 terms and then grouped it. Excuse me, here's another example of the same thing. We have x squared plus 5x plus 3x plus 15. Right now, I want you to resist the urge to combine those two terms. I'm just doing this as an illustration. Okay, I want you to see the illustration that we can group them, factor out an x, and we'll have x plus 5. Factor out a 3, and we'll have x plus 5. And then we have x plus 5 times x plus 3 as our factored form. Now, this is what I want you to do. Take a minute, take that last factored form, x plus 5 times x plus 3, and I want you to FOIL it. FOIL it. If you FOIL it, that means first times first, you get x squared. Then outer would be x times 3, which is 3x. Inner would be the 5x. And the last would be the 15. Look at the 4 terms that we got when we FOILed it. When we FOILed it, we got those 4 terms. But aren't these the same 4 terms we had up here when we first started? X squared plus 3x plus 5x plus 15. They're not in that order, but it's the same 4 terms. So actually, what we did really was kind of like unfoil. You know, when we factored it, it's kind of like we unfoiled it into those two binomials. So let's look at 1 or 2 more examples. Look at this one. We have y squared plus 8y minus 2y minus 16. Resist the urge to combine the middle 2 terms. If we combine them, it would be plus 6y. Okay? But let's leave them separated. Okay, leave them separated and let's group them. We'll have y squared plus 8y plus negative 2y minus 16. Remember, you have to keep the negative with the 2y. So I'm going to group them like that. And with the first binomial, I will factor out a y, and I'll be left with y plus 8. The second one, I'm going to factor out a negative 2, and I'll be left with y plus 8. So we'll factor out a y plus 8, and it'll leave us a y minus 2. This is the factored form. So we've taken a 4-term polynomial and factored it into 2 binomials that are multiplied. Let's do one more like this. We have 8x squared minus 5x minus 24x plus 15. Look at the 8x squared. Look at the negative 5x. Look at the negative 24x. Don't combine them. Leave them separated for the sake of illustration. Okay, I want to write this again. Grouping the first 2 terms, plus I want to group the second 2, keeping the negative sign with the 24x. So in the first binomial, I can factor out an x, and it will leave me 8x minus 5. The second binomial, we can factor out, I want an 8x minus 5. If I just factor out a 3, I'm going to get a negative 8x plus 5, but I don't want that. Let's factor out a negative 3, and that will change the x term to positive. So that will be 8x minus 5, which is what we want. And then bring out the 8x minus 5. It'll leave us x minus 3. All of this is introduction to what we're going to be doing in the next slide or so. Okay? Now, let's take a trinomial and make it into a 4-term polynomial so that we can factor it by grouping. Remember, if you have a 4-term polynomial, it's easy to factor it because all you have to do is group it. But many times you're going to be given a trinomial, which is a 3-term polynomial. We can make a 3-term polynomial into a 4-term polynomial by separating the middle term into 2 parts. So watch what I have here. Look at 21y squared plus 17y plus 2. Now, if we could separate 17y into 2 different terms, that would help us to factor this. We could separate 17y a bunch of ways. We could have 1y and 16y, 2y and 15y, 3y and 14y. They all add up to 17y, right? 10y plus 7y. That's 17y. 9y plus 8y. We could separate 17y into 2 parts very, very easily. But I want to choose the most, the strategic way that is going to allow me to factor this correctly. So what we do, in order to pick the correct numbers to put into these pink boxes, because I want to break up the 17y into 2 terms so that now we will have 4 terms to deal with. But what we do is, this is where the AC method comes in. We look at our A, which is the 21, and our C, which is the 2. This is this, well, I'm going to erase that. This is the C. This is the A part of your equation. I'm sorry, polynomial. The A and the C. What you do with the A and the C is you take them, multiply them together, considering the signs and all. 21, the A, times 2, the C. Well, what's 21 times 2? 21 times a positive 2 is 42. Now, you know how when we factor a trinomial, we ask ourselves what two numbers multiply to the end number, but add to the middle number, add together to get the middle number? I went through that in 6.2. You know how we always say, what two numbers multiply to this, but add to this? Well, you see this 42? We're going to use 42 to say what two numbers multiply to 42 multiply to 42 and add to 17. What two numbers multiply to 42 but add to 17? You have to think kind of out the box. I need two numbers that multiply to 14 and add to 17. Well, sometimes you can't think of them right away, so you have to kind of make a list. I go off to the side and make my list. Well, I know it can't be 42 and 1 because no kind of way can I add a 42 and a 1 to get 17. What about what's another number that divides into 42? 6 and 7. 6 and 7 multiply to 42, but will they add to 17? 21 and 2. Can that add to 17? No, but you have to really think out the box, and you have to think about 3 and 14. Because 3 times 14 is 42, but 3 plus 14 adds to 17. So what you're looking for now is two numbers that multiply to 42 that you got from from your AC and add to 17, which is your middle term coefficient. So the two numbers that we're looking for are 3 and 14. You're not going to get this right away, but just pay attention. We're looking for 3 and 14. 3 goes one place, 14 goes the other. Notice where I just placed them. So what I did was I took 17y and broke it up into two parts. 3y plus 14y. Okay? You can't argue with me and tell me that that does not equal 17y. So all I did was take the 17y and separate it into two parts. But I had to separate it into these special parts. I couldn't just make up some numbers. But the way you figure the number out is by multiplying the A and the C together. And that's the only thing we're going to use that 42 for. We won't use the 42 at all in this problem anymore. So now we have a new polynomial. The polynomial we have is 21y squared plus 3y plus 14y plus 2. Now we can group the first two and the second two, and we can factor out a 3y, and that will leave us a 7y plus 1. And over on the other side, we can factor out a 2, and it will leave us 7y plus 1. And then we factor out a 7y plus 1, and then we have 3y plus 2. So believe it or not, this looks like a whole lot, But this is, in my opinion, very, very easy compared to the stuff that's in section 6.3. Because in 6.3, you're using a method that's called guess and check, or trial and error, where you're just trying numbers to see what's going to multiply, and you end up with 5, 6 different binomials that you're trying to set up. I don't have time for that. I want to go directly to the correct binomial. So we have just factored the original polynomial that we had. Won't get it the first time. Let's move to another one. I've taken the time to break this one up so you can see what we're doing. Notice what's happening. The leading coefficient is not a 1. You don't do this when the leading coefficient is 1. You don't have to. But when the leading coefficient is not a 1, like this one is a 15, you go use the AC method. So we take the A and the C and multiply them. That's the first thing. Multiply 15 and 2. And we get 30, positive 30, because both of those numbers are positive. Now I want two numbers that multiply to 30. But add to 11. The 11 is the coefficient of the middle term. So what two numbers multiply to 30, positive 30, and add to 11? 5 and 6. They multiply to 30, but add to 11. Good, 5 and 6. So we'll take the 5 and 6. I'm gonna put the 5 right here with the 15. I'm gonna put the 6 over here with the 2, so that we can group them. So I'm gonna rewrite my polynomial now with 4 terms. Everything is positive in this polynomial, so it's easy to group them with your parentheses. Now, I'm going to factor out a 5x. That leaves me 3x plus 1. And I'm going to factor out a 2, and I'll get 3x plus 1, which ultimately leaves me with 3x plus 1 times 5x plus 2. I'm sorry it's bunched up like this, but that is the factored form. And remember, we never touched that 30 again. All we used the 30 for was to tell us what, to help us figure out what two factors we needed. Look at the next one. The leading coefficient is not a 1, and you can't factor out a GCF to make it a 1. Look at 3x squared plus 14x plus 8. Leading coefficient is 3. You can't factor anything out. So this is when you know you have to use the grouping method or the AC method. Multiply your 3 times 8. 3 is positive, 8 is positive. So we're looking for two numbers that multiply to 3 times 8, which is 24, and add to 14. 14 is the middle coefficient. So two numbers that multiply to 24, add to 14. Is it 6 and 4? Will 6 and 4 add to 14? No, but it'll multiply to 24. Well, 8 and 3, they multiply to 24, but they don't add to 14. What about 12 and 2? 12 and 2 multiply to 24 and add to 14. So those are the two numbers that I want to separate my 14x into a 12x and a 2x. So I rewrite the whole thing, 3x squared plus 12x plus 2x plus 8. Okay, so then I want to group them with parentheses and then factor out what's common to each binomial. What can we factor out of the first one? 3x, and we have an x plus 4. Then we can factor out a 2, and that leaves us x plus 4. Factor out an x plus 4, and then we have 3x plus 2. So we have factored this polynomial by grouping. Next, look at this one. 5x squared plus 61x plus 12. Is the leading coefficient a 1? Nope. Can you factor out any GCF? Nope. So you know you have to use the AC method. So AC says multiply 5 times 12, positive 12, positive 5, so that's a positive 60. So I need two numbers that multiply to 60 but add to 61. That's easy. That would be 60 and 1, right? Multiply to 60 but add to 61. So let's rewrite it. The whole thing now, 5x squared. I'm going to go plus, let's see, 60x plus 1x. I'm going to put the 1 just so you can see 1x plus 12. Okay, you see what I did? I broke 60x up into 61x into 60x and 1x. Then I'm going to group with parentheses. All right, what's common to the first binomial? 5x, and it leaves us an x plus 12, right? What's common to the first thing? The next binomial? Nothing but a 1, huh? Factor out a 1. Honestly, it leaves you x plus 12 if you want to write it like that. But you have to identify the fact that there's a 1 there. Okay? If you don't see a 1, you put a 1. So x and 12 basically don't have anything else in common other than 1. That's all we're saying. So you factor out a 1. Now we have x plus 12 times 5x plus 1. Don't be tempted to leave this blank or leave this blank. You can't. You have to put a 1 there. Because when you multiply it out to check it, you have to come up with 4 terms. And you can't leave out that 1. The more you do, the more you'll understand what I'm saying here. Look at the next one. 6x squared minus 13x plus 7. Is the leading coefficient 1? No. Can anything be factored out to make it a 1? No. So we use the grouping method that says multiply 6 times 7. That's a 42. So I need two numbers that multiply to 42 and add to negative 13. They multiply to 42 but add to negative 13. So if two numbers multiply to 42, positive 42, they either have to both be positive or both be negative, right? But if they add to a negative 13, then that means they both have to be negative. So what are our two numbers? Negative 6, negative 7. They multiply to 42, but add to negative 13. So I want to come back, break up this 3-term polynomial into a 4-term polynomial. I'm going to put minus 6x, then minus 7x, plus 7. Okay? Then I'm going to rewrite it and group everything. 6x squared minus 6x plus, now keep the negative with the 7x. Okay? What can be factored out of the first binomial? 6x. And it leaves us an x minus 1. What can be factored out of the... So we want x minus 1. If we factor out a 7 out of the second binomial, then we're going to get negative x plus 1. We don't want negative x plus 1. We want x minus 1. So we have to factor out a negative 7, and that's going to change the sign of the x to positive, and the 7 will become a negative 1. Okay? Take a minute and look at that to make sure you understand what I did. I factored out a negative 7, which made the rest of it, at the remaining terms, the x became positive, and when we divided out that negative 7, that left us with a negative 1. Okay, so we have x minus 1 times 6x minus 7 as our factored form. If you multiply this, you're going to get the exact same terms. If you FOIL it, you're going to get those exact same 4 terms that we started out, that we got after we broke it up into 4 parts. All right, here's another one. 12x minus 19x plus 5. Is the leading coefficient 1? No. Can anything be factored out of all 3 terms? No. So we use the AC method. We multiply 12 times positive 5. That's a 60. Now what 2 numbers multiply to 60? Positive 60, but add to negative 19. Think about it. It has to multiply to positive. So that means both numbers are either positive or both numbers are negative. But they have to add to a negative 19. So they have to both be negative. So you might take a minute. I know what it is, but you might have to say, well, it can't be 60 and 1 or negative 60 and negative 1 because that won't add to a 19, right? Negative 60, negative 1. Can't be those two. What about negative 30 and negative 2? That multiplies to 60. Will that add to negative 19 though? No. What about negative 20 and negative 3? Will that multiply to 60? Yeah, but will that add to 19? Negative 19. No. So you have to try sometimes. You have to go through a few different factors. But here we're going to have negative 15 and negative 4. That multiplies to 60. And it adds to negative 19. Now, even with all of this right here, it's still easier than doing the stuff in 6.3. So rewrite the polynomial, 12x squared, but I want to break the negative 19x up into negative 15x and negative 4x. I'm going to put the negative 4x first and the negative 15x second, because I want the 15x to go with the 5 and I want the 4x to go with the 12 so that we can group them, and it looks like it will work that way. So let's group 12x squared minus 4x, group them, plus negative 15x plus 5. Factor out a 4x from the first one and we'll have 3x minus 1. Factor out a negative 5, and we'll have 3x minus 1. So then we take 3x minus 1 and factor that out, and we're left with 4x minus 5. And that's the factored form. The next one, 6x squared y minus 7xy minus 5y. Do you hear what I said? 6x squared y minus 7x squared y minus 5y. Is the leading coefficient a 1? Nope. Is there a GCF? Do they have a common factor that can be factored out? Yes. It's a 1. I'm sorry, y. And when you factor out the y, what you're left with, oh, sorry about that, what you're left with is 6x squared minus 7x minus 5. So we have an extra step that we've done. We had to factor out the GCF of y. Now what you have to be careful about with this is that y is going to be part of your final answer. So I like to just kind of remind myself, move the y out of the way and let it wait for me at the bottom of the page, at bottom, give myself some space to work this factoring out, and it will be waiting for me at the end. Y is going to be one of our factors when we finish this whole process. But in the meantime, go back to the trinomial and ask yourself, is the leading coefficient a 1? Okay, no. We've already factored out everything that's common, so now we need to go to the through the steps of multiplying. So a times c, 6 times negative 5 is negative 30. So we want two numbers that multiply to negative 30, right? But add to negative 7. Negative 30, add to negative 7. Now remember, when two numbers multiply to a negative, that means one of the numbers has to be positive and one has to be negative. That's the only way you can multiply two numbers and the answer is negative, is if one is positive, one is negative. But they have to add to a negative 7. Okay, what two numbers multiply to negative 30 but add to negative 7? Take a minute, think about the different factors. 15 and 2 multiply to 30. So if one of them is negative, one of them is positive, you can get a negative 30. But will that add to negative 7? No, it won't. So after you make a list, you will find that negative 10, positive 3, those multiply to negative 30 and add to negative 7. 3 plus negative 10 is negative 7. So those are the two numbers we want to use to break up our 7x in the middle. So we have 6x squared minus 7x, but we're going to break it up into, let's see, we can do the plus 3x minus 10x minus 5. You didn't have to do it that way. You could have put the negative 10x first. Okay, so I'm going to write them now and group them. 6x squared plus 3x grouped together plus negative 10x minus 5 grouped together. Factor out a 3x and we'll have a 2x plus 1. Factor out a negative 5 and we'll have 2x plus 1, and factor out now 2x plus 1, and we end up with that times 3x minus 5. All of that times this y that we brought down. So your final answer is y times 2x plus 1 times 3x minus 5. Don't forget the y or whatever your GCF is. Okay, I'm going to walk through these. I'm going to factor out a 2. That's the GCF. So if I factor out a 2, I'm going to be left with 15x squared minus 7x minus 2. All right, I don't have a leading coefficient of 1, so I have to multiply 15 times negative 2, so that's a negative 30. And I want it to add to negative 7. Okay, we have the same numbers here. Negative 30 two numbers that multiply negative 30 and add to negative 7. Well, that's going to be a negative 10 and a positive 3, right? Well, it works out this way. So I have this 2 that's going to wait for me down here at the bottom, and I'm going to go back and rewrite this as a 4-term polynomial. I'm going to put the negative 10 here, just so you can see, plus 3x minus 2. It looks like the 3x and the 2 don't have anything in common, but watch what happens when we group them. They do have a 1 in common, so keep that in mind. 15x squared minus 10x, we can factor out a 5x, and that leaves us a 3x minus 2. What's common to 3x minus 2 that can be factored out? A 1. Well, we have 3x minus 2, which is what we wanted. So ultimately we have 2, our 2 down here, right, times, we're going to bring the 3x minus 2 over and multiply that by 5x plus 1. And that's your ultimate answer. Two times 3x minus 2 times 5x plus 1. Okay, the next one I'm going to factor out a 2 and a y cubed. And it's going to leave me a 6y squared plus 5y minus 21. And the 2y cubed now is going to be the thing that's going to follow me and wait for me all the way at the bottom while I work out the trinomial. So, oh my, I got to multiply 6 times negative 21. Okay, so let's see. I have to use my calculator here. 6 times negative 21. So that's a negative 126. So I need two numbers that multiply to negative 126 but add to 5. This one's going to take a minute. So let's try. We know it's not going to be 126 and 1. It's not going to be 2 and anything. Well, what 126 divided by 2 is 63. Will that multiply or add, I'm sorry, any kind of way to give us a 5? Well, no. What about 3? Will 3 go into 126? 3 and 42. Will that give us a 5 any kind of way? No. What about 4? 4 doesn't go into 126. 5 doesn't go into 126. 6 does. Let's see. 126 divided by 6 is 21. So 6 and 21. Will that add some kind of way to give us a 5? What about 7? 7 and 18. Did I do it right? 126 divided by 7. 7 and 18. Can I get a 5 out of that some kind of way? Nope. What about 8? 126 divided by 8. Nope. 126 divided by 9. 14. 9 and 14. 9 and 14. Something about 9 and 14 sounds like 5 to me. I can combine a 9 and a 14, one positive, one negative, to get a 5. There's a difference of 5 there. So I need the 5 to be positive, though. So that means the 14 has to be positive. The 9 has to be negative. That will multiply to negative 126 and add to positive 5. Okay, those are my two numbers. Positive 14, negative 9. So let's rewrite 6y squared. I'm going to go with negative 9y plus 14y minus 21. Remember, you're breaking up the 3-term polynomial into a 4-term polynomial so that now you can group. I'm going to go ahead on and group them since the positives are in a good spot. Factor out a 3y, and I'm going to have 2y minus 3. Factor out a 7, and I'll have 2y minus 3. So down to my bottom term here, I have 2y cubed times 2y minus 3 times 3y plus 7. This is the factored form. So here you have 3 factors. Okay? Sometimes the hardest thing is finding the 2 numbers that you're looking for. But just take your time. 40m to the 4th plus 5m cubed minus 35m squared. We can factor out a 5m squared, and that will leave us 8m squared plus m minus 7. Eight m squared plus m minus 7. Okay, that's right. So the 5m squared is going to follow us all the way to the bottom. And now I have to work with 8m squared plus m minus 7. Leading coefficient is an 8 instead of a 1, so we have to multiply 8 times negative 7. 8 times 7 is 56, so that's a negative 56. Need 2 numbers to multiply to 56. Negative 56, but add to a positive 1. Well, 7 and 8. Well, what about 7 and 8? I need a positive 8 and a negative 7. Those two multiplied will give me a negative 56, but added will give me a positive 1. So let's break it up. 8m squared plus 8m minus 7m minus 7. And I'm going to group them. 8m squared plus 8m plus negative 7m minus 7. Factor out 8m. And we get a m plus 1. Factor out a negative 7. And we get m plus 1. Okay, so then we can take that m plus 1. I'm going to write it all in pink now. I'm going to bring my 5m squared down. I have m plus 1 times 8m minus 7. And that's our final answer. Look at the next one. 9x squared minus 42x. Okay, so when you look at this one, you ask yourself, is there a GCF that can be factored out? There is none. Okay, 9, 42, and 49 don't have anything in common. So your next thing would be to go ahead on and multiply the 9 times 49. And 9 times 49 is 441. I went ahead and worked this one so I can get the numbers together. But after you figure out what the two numbers are that multiply to 441, positive 441, and add to a negative 42. After you've done a little searching for those numbers, you will find that it's negative 21 and negative 21. Okay, multiply them together, you get 441, and add them together, you get negative 42. So we take them, and we spread out the 3-term polynomial into a 4-term polynomial. Okay, so that now we can group the first 2 terms and the second 2 terms. Looking at the first one, we can factor out a 3x, and it leaves us a 3x minus 7. The next one, we can factor out a negative 7, and it leaves us a 3x minus 7. But watch what happens here. When you bring out the 3x minus 7 that's common, what you have left is 3x minus 7. And this is a binomial squared, 3x minus 7 squared. But remember in the last chapter when we were multiplying binomials, and we had the pattern, when you multiply a binomial times itself, it always ended up being, remember, it would end up being the first term squared plus or minus twice the first term times the second term plus the, let me go ahead on and rewrite it, the whole thing. If you have a binomial squared, like a plus b, and you square it, you get a squared plus 2 times ab plus b squared. Well, that's what this original expression is. It is a perfect square term. Look at it. 9x squared is a square term. 49 is a square term. And the middle is 2 times 3 times 7. What am I talking about? What do you square? Look at the original expression. What do you square to get 9x squared? What do you square to get 9x squared? It's a 3x. What do you square to get a 49? It's a 7. Okay? 3x and a 7. But is the middle term twice that? Twice the 3x times the 7. Yes, it is, because 3x times 7 is 21, and 21x, and that times 2 is 42x. So I'm saying that to say, if you looked at this original expression, you could have recognized that it was a perfect square trinomial and then just factored it without going through all of the grouping if you recognize it. And I told you in the last chapter, there were some patterns that you should be able to recognize, and it will help you to save time. But look at this one. Look at this one. Before you start factoring, just take a look at it. 16x squared plus 24x plus 9. Before you start grouping it, first look to see if there are any GCFs. Is there a GCF? They can be factored out. No. Then ask yourself, okay, is the leading coefficient 1? No. So you might want to start grouping. But before you start grouping, look at it again closely. Is 16x squared a square term? Meaning, is a 16 a square and x squared a square? Yes, but what do you square to get 16x squared? 4x. Is 9 a square term? Yes. What do you square to get 9? A 3, right? So look at them, instead of looking at it as 16x squared, look at it as a 4x and a 3. And ask yourself, is the middle term now, is the middle term 2 times 4x times 3? Is it? Is the middle term 2 times 4x times 3? Yes, it is. So this trinomial is what we call a perfect square. If you go through this in your mind, you will be able to quickly factor this. And you say, okay, well, since that 16x squared is a square term, 9 is a square term, and the middle term is 2 times 4x times 3, then I know I can easily factor this into 4x plus 3 squared without going through all of that factoring and grouping and stuff. But if you don't recognize it, you still can do the grouping. You still can do the grouping if you say, well, 16x squared plus 24x plus 9. Multiply the 16 times the 9. That's 144. What two numbers multiply to 144 but add to 24? Well, that's 12 and 12. So rewrite it. 16x squared plus 12x plus 12x plus 9. Group them. Then factor out a 4, I think, x. And that will leave you 4x plus 3. And then over on the other side, you'd factor out a 3. And it will leave you 4x plus 3. And when you write it all out, you have 4x plus 3 times 4x plus 3, which is 4x plus 3 quantity squared. So the thing is, if you recognize a perfect square trinomial, you can go straight from the trinomial to the factored form. If you don't recognize it, you're going to have to go through this, and this. So it can save you 2 or 3 steps if you recognize a perfect square trinomial. We'll talk more about that when we go back into section 6.3. I'm going to touch on a couple of concepts in 6.3, and you'll see a bit more of this. Okay? Good luck.